Hello, everyone, and welcome to another episode of Kelly Telly. Today, we're going to be talking a little bit about the topic of air. Before we get into it, however, I want you to just take a minute just to kind of sit back, get into a nice, comfortable position, maybe stretch out your legs a little bit, roll your shoulders back, and you might be clenching your jaw as well. Just try and relax your jaw a little bit. And yeah, just basically pay attention, and we're going to talk a little bit today about air. So, what is air? We know we need it to breathe. All biological organisms on Earth need it to breathe in some way, some part of that respiration reaction that's important for life. We also know that it keeps us warm. So, the greenhouse gases that are in the air actually trap heat from the sun and keep the Earth at a basic, very special temperature, one that allows us to basically live at all times. But we want to know a little bit in more depth what exactly is air. So let's have a look at a definition here. So air is the name we give to the collection of gases that exist within the atmosphere of Earth. So I'm going to say that again. Air is the name we give to the collection of gases that exist within the atmosphere of Earth. So what is the atmosphere? Well, if you have a look at the grass in this picture just here, that and anything kind of below that or just on top of that is what we call the biosphere. And anything above that, all the way up 1,000 kilometers up towards space, is what we call the atmosphere. So it's all of that space between the biosphere and the very end, the edge of space. That edge of space is actually called the Kármán line, and that is the line that basically tells us this is where the atmosphere ends and this is where space begins. So that area there is what we call the atmosphere, and whenever we're referring to air, some people will use the term as a basically a replacement for the word oxygen. But what the true definition of air is that it's a collection of the gases. So there's a multiple different gases that exist in that space. I'm sure you could name a few of them off your head: carbon dioxide, nitrogen, um, and what I want to show you next is actually kind of linked in with all of this. And the thing I want you to kind of make the link, particularly in this video, is that air is made up of gases. Those gases are made up of particles. So what I want you to bring into the next part is just your understanding of particle theory and how particles move around constantly, and whether and gases have all of these different particles that are moving around at very fast rates. So I've got a simulation here from the CSIRO, which is the Commonwealth Scientific and Industrial Research Organization, if you didn't know. And essentially what this simulation is showing us is air. But it's not air as we know it. Obviously, they're not those colors. This is at 0 degrees Celsius, so obviously the particles are a lot slower, and it's actually slowed down 417 billion times. So 417 billion times is what we have is what like speed is what we have here. So we can see that there's a bunch of different molecules, what we call atoms joined together, all floating around in the air here. We have different actual types of molecules. You can see that one just that came in from the left, and you can see some yellow ones up there, the blue ones, red ones, and they're all meant to simulate different types of gases because our air is made up of many gases. Let's have a look here at what those gases are. So we've actually got a few bits of scientific data here. On the left-hand side, we have a table here that shows all the different percentages of the common gases or elements found in air. And over here we have a pie chart showing basically the exact same thing. So don't get too confused by this. Let's just break it down together. All right, so having a quick look at nitrogen being one of them, 78% of all air is made up of nitrogen, basically. I think this was of 2015. It might be a bit of an old table. It shouldn't have changed too much. And we have 20% made up of oxygen, or almost 21%. Argon, we have almost a full percent of argon, and then we have a bunch of other gases. So we have neon, helium, hydrogen, xenon. These are all just different elements. Some of them, in their elemental form, hydrogen isn't too stable just on its own, so it's usually pairs up there, as does oxygen and nitrogen. But we also have other things in the air. So obviously there's some more gases here: carbon dioxide, methane, nitrous oxide, ozone, those kind of things. But we also have things like water vapor and particles, and also chlorofluorocarbons, which are actually, they're not actually gaseous particles. Some of them are liquids, some of them are solids. But what they are, they're actually, if you picture that simulation that we just looked at, all those air molecules are kind of like even tighter packed than that. They probably don't have that much space between them. And what happens is little bits of solids actually get caught in the air. If a leaf gets picked up in the wind, for example, but think about if that instead of a leaf, it's a tiny microscopic like particle, like something like dust or soot. And we call these particles that are kind of mixed up in the air, we call them aerosols. You may have heard the term aerosol referring to deodorant because it actually puts like solid particles into the air. Uh, Basically, obviously, in that case, to create a nice scent. But there are just aerosols floating around in the air. So air is like this mixture of just a bunch of different things, all kind of combined together. And if this kind of whole page and stuff is confusing, let's go to one that's a little bit more simple. Yeah, so essentially just breaking it all down. So reminding ourselves, air is that mixture of all the different gases that exist within the Earth's atmosphere, and this is a quite a simple, nice breakdown of that. So we have a pie chart here. It's showing that 78% of all gases are nitrogen, 21% of all, 78% of all like atoms, molecules in the air are nitrogen. 21% of those atoms are oxygen. We have 0.04% of carbon dioxide. And then we have like a bunch of other gases that make up the remaining 0.96%. As I said, mostly argon's quite a lot of that. So this is basically the breakdown of air. There wasn't too much more I wanted to go through, but I just wanted you to make sure that you do have that solid understanding of what air is. So thank you so much for listening and have a great day.